Hello students, today we are going to discuss assertion and reasoning type questions. What are assertion and reasoning type questions? How you should attempt it. We'll discuss how the students in general try to attempt such questions and what are the problems faced by such students. We'll also discuss what you should do for attempting assertion and reasoning type questions. That means we'll discuss a more systematic and scientific way in which you should attempt such problems there. We'll also discuss the common mistake which the students make in such problem there and due to which they lose marks, they are not getting the correct option there. So let's first of all discuss what is the usual way the student attempt such questions and what is the common mistake the students make in such problems. First of all, the student treat it like a normal MCQ type question, that is the multiple choice question. Now you will say that this is also a multiple choice question where you have been given 4 options and you have to select the correct option based on the assertion and reason statements. That's true. But still, if you go for the normal MCQ type questions, not the assertion and reasoning type, and if you compare it with the assertion and reasoning type questions there is difference. And you should also make a change in your way in which you attempt such problems. First of all, let's discuss how it is different. If you go for a normal MCQ type question, you have been given one statement, one question is there, and you have to attempt for its correct option. For that, you have been given 4 options there, and you have to select the correct one. In assertion and reasoning type question, you have been given assertion and reason there. 4 options are there. You have to select for the correct option there. But here, what you have to do, you have to go for the assertion and reasoning statements, and based on that, what are the options which are given in the problem, you have to choose for the correct option. And normally, if you go in a traditional way in attempting assertion and reasoning type questions, you are likely to spend more time. Now, why is it so? We'll discuss now. So first of all, let's see that what are the assertion and reasoning type questions there. You have assertion and reasoning type questions there. In assertion and reasoning type questions, you will be given 2 statements. One is the assertion and other is the reason. And then there will be 4 options given there. The first option is, suppose assertion and reason both are correct statement and reason is the correct explanation for the assertion. Second option is there, assertion and reason both are correct statement but reason is not the correct explanation for assertion. Third one is there, assertion is correct but reason is wrong. Fourth one may be that assertion is wrong statement and reason is the correct statement. Fifth also we get where assertion and reason both are wrong statements. Of course, if you out of 4 options only you have to select the correct one. Normally we have the 4 options given for a particular multiple choice question there. In that case, there may be first, second, third and fourth given there. Or it may be your first, second, third and fifth one. In fact, you have to see first of all what are the different options given from which you have to select. So don't take it guaranteed that these 4 on which you have practiced will be asked also in the examination. Like first one, that assertion reason both are correct, reason is the correct explanation of the assertion. Second one, that assertion and reason both are correct statement but reason is not the correct explanation of the assertion. Third one, assertion is true but reason is false. Fourth one, both are wrong. Or it may be that assertion is wrong and reason is false. So you just see for a particular question that what are the options given there, and accordingly you have to select the correct option there. Now here, what is the usual way the students attempt? Normal MCQ questions, if you see, then we read the statement, we read the question, and then we search for the correct option out of the 4 which is given there. Once we get it, we select that one or we choose that. Normally, the students attempt the same method for this type of problem also. That means what they will do, they will read the statement of the assertion and reason. After that, they will go for the first option. If they find that this is not the correct one, then they will go for the second one, then third, then fourth. And here what happens there, normally, that the student, if they have read statements of assertion and reason, now they are going for the first option, where it is said that both are correct and the reason is the correct explanation for the assertion. They would like to think whether it is correct or not. So for that, they again go back to the assertion and reason statement. If they find that it is not the correct one, then they go for the second one, then the third one. So here they have to often go for that statement part. So obviously they will be taking longer time. And once they are taking longer time, in that case, they may choose in a hurry any of the options there, which may not be the correct one. So here, what you should do for such type of problems, we'll discuss that what is the correct way or scientific way for doing such problems there. Now, I will suggest that for normal MCQ type questions, if you are reading statement first or the question first, then you are going for the different option. Here, in assertion and reasoning type question, first you read what are the options given. That is just a reverse way. And then you read the statement of the assertion and reason. So now you know that what are the options for that particular question. Like you know that assertion and reason both are correct and reason is the correct explanation. This is the first option. The second one is assertion and reason both are correct and reason is not the correct explanation. That is the second one. Third one is that assertion is true, reason is false. Fourth one is suppose there that both are wrong statement. So now you know that out of these options, according to the statement which is given, you have to choose. So here, this method you cannot apply for the normal MCQ type questions, because reading out the options there is meaningless. So there we read the statement of the question first and then we go for the options. But for assertion and reasoning, I will suggest go through the options which is given there and then you go for the assertion and reasoning statements. Now after that, what you should do? Assertion and reasoning type questions you treat as a combination of two types of questions. One true and false and other one reasoning type. Now what does it mean? Once you have read the options from which you have to select the correct one, now you do that you take the assertion and reason statements and check whether it is true or false. So suppose you find that assertion is false and reason is also false. If both are false, that means the fifth one which is given there, assertion and reason both are wrong statement, is the correct option in there. But if you find that assertion is true but reason is false, so in that case it is the third one which is the correct one. Similarly, if you find that assertion is false, but reason is true. In that case, it is the fourth one which is the correct option. So outrightly, you can choose for the correct option once you know what is the status of the statement of the assertion and reason. So if both are wrong or either of them is wrong or it is true, in that case, it is easy to select. But problem will arise when both are true. In that case, you have to decide whether it is the first option which is correct, where reason is the correct explanation of the assertion, or the second one where it is not explaining it properly what is given in the assertion, although both are the correct statements. So for such type of problem where assertion is true, reason is also true, I will suggest what you do, you read the assertion first, then use a word because, and then read the statement of the reason. That means assertion followed by because, and then it is the reason. Does it make sense? If it makes sense, it appears the correct statement altogether. That means the first one is the correct option. Just like suppose if one option is there that electric lines of forces never intersect each other. This is a true statement. And the reason is given that if they intersect, that at the point of intersection there can be two directions of electric field, which is not possible. Now just read it the way I have told you. Electric lines of forces never intersect each other because if they intersect, then at the point of intersection there can be two directions of electric field, which is not possible. So now altogether it appears a correct statement. So this is the first one which is correct statement. That means first one will be the right correct choice there. But suppose if the second statement which is given, that is the reason which is given, is that electric lines of forces do not form closed loop. First is given that electric lines of forces do not intersect each other, assertion, and reason is given that they do not form closed loops. Both statements are correct. But if you read it now, electric lines of forces do not intersect each other because they do not form closed loop. It does not make any sense. So in that case, the second one will be the correct option. So this is how you have to do assertion and reasoning type questions stepwise. In that case, you can quickly come to the correct conclusion and the option there. Now we'll discuss some of the questions of assertion and reasoning type, which was there in the sample paper released by the CBSE. And we'll just try to practice this method to solve such problems. And we'll see that how quickly we can get the correct answer. Let's take the first question. Here, the different options which are given, assertion and reason both are correct statement, and reason is the correct explanation of the assertion. Second one is that assertion and reason both are correct statement, but reason is not the correct explanation of the assertion. Third one is there, assertion is correct, but reason is wrong statement. And the fourth one, assertion and reason both are wrong statement. Now let's come back to the statement. Here we'll first decide whether it is true or false. Assertion is to increase the range of an ammeter, we must connect a suitable high resistance in series to it. You know that in ammeter, we connect low resistance. We need ammeter to have low resistance so that it can measure the current accurately in the given circuit there. So obviously this is a false statement, or it is wrong statement there. Second one, that is the reason. The ammeter with increased range should have high resistance. Again, ammeter should have low resistance there. So obviously in this particular case, this is also false or wrong statement. So in that case, which is the correct option? Definitely the fourth one is the correct option there. because both are wrong. So once we know that what are the options there, we don't have to go for those different options there. Once we have seen that it is the both are wrong statement, obviously the fourth one is the correct option there. Now let's take the second question. An electron has high potential energy when it is at a location associated with more negative value of the potential, and low potential energy when at a location associated with more positive potential. Now you know that potential at a point, when we take, it is your Q by 4 pi epsilon naught R if you are taking the point charge there. And all these terms, like the potential, electric field and other, all terms of the electrostatics, even the current electricity, we define in terms of the positive charge. So the point which has higher value, that is the positive value, will be a point of high energy or high potential for positive charge, and it is low for negative charge. So obviously if it is said it is high potential energy when it is at a location with more negative value, that means this is a correct statement or it is true. Now second one, electron move from the region of the high potential to a region of low potential. Remember, I have already told you that potential, electric field, all the terms there are defined by taking positive charge as a standard. So here, if we take the positive charge, it will move from high potential to low potential, because charges move from high potential to low potential. But for electron, they will be moving from the point of low potential to high potential. Now that doesn't mean they are violating the statement that charges move from high potential to low potential, because the point of low potential is a point of high potential for electrons. So if you look at this statement, electrons move from the region of high potential to low potential or lower potential. This is an incorrect statement or it is false. So here assertion is true, but reason is false. So in that case, which is the correct option? The third one will be the correct option. Let's take the next question. Assertion is, of course, again the options which we have taken is the same one. Assertion and reason both correct. Reason is the correct explanation of the assertion, that is the first one, and assertion and reason both are correct statement, but reason is not the correct explanation. This is the second. Third one is that assertion is correct statement, reason is wrong statement, and the fourth one is that both are wrong statement. So again, in this particular case also, the same set of option is given there. Now let's take the assertion statement. A magnetic needle free to rotate in a vertical plane orients itself with its axis of the vertical to the poles of Earth. If you take a freely suspended magnet, it aligns itself in the north-south direction. But the same magnet, if you take the pole and there if you suspend it freely, in that case it will get aligned in the vertical direction, because the magnetic pole will be just beneath your feet there. So in that case, it will just become vertical there. Because if you take a magnet, suspend it freely, it will try to get aligned in the direction of the magnetic field, because in that particular orientation, on that the torque will be 0. That is why if I release it anywhere there freely, in that case it try to align in the north-south direction. Earth's magnetic field is also along the same direction there, so the torque will be 0 there. So that means this is the correct statement. True. And the reason is that at the pole of the poles, the horizontal component of the Earth's magnetic field is 0. This is also true, because at pole you will only have the vertical component. At normal position, if you take the orientation of the magnet, it will have the horizontal and vertical component there. But if you are there at the pole, the field is there in that vertical direction, so there is no horizontal component. In that case, this is also true. And remember, magnet will align in the direction of the magnetic field. And if there is no horizontal component, that means it is in the vertical direction. So obviously, this is explaining it correctly, because if I read the statement, magnetic needle free to rotate in the vertical plane orient itself with its axis vertical at the pole of the earth, because at the pole of the earth, the horizontal component of the earth's magnetic field will be 0. So this is, the first is correct. Let's take the next question. Now the next question is again the different option. It is the same options again here. First, both true, correct explanation. Second, both true but not the correct explanation. Third one, assertion is correct, reason is wrong, false. And the fourth one, assertion and reason both are false. Now in this case, if you take a proton and electron with same momenta enter in magnetic field in a direction at right angle to the lines of force, the radius of the path followed by them will be same. Okay, so let's just first of all take what is the force on the charged particle in the magnetic field. Formula is QVB sine theta. Now here it is given that they are moving at right angle to the magnetic field. So it is your sine pi by 2. This is the force which will provide the necessary centripetal force, because the magnetic field and velocity is perpendicular. So the path will be circular. So this will be your mv square by r. Now, so I can take here, this v will get cancelled with v square term. Now it is your QB equals to mv by r, or r will be equals to mv by QB. Now, what was the given in the statement? That the radius of the path followed by them is same if they are moving with the same momenta. If you consider mv, this is the momentum. So it is same, that means the numerator term is same magnetic field is there, charge term is there, charge on the proton and electron is same, so the radius will be same. So that means this is the correct statement. So this is true. Now, second one is there, electron has less mass than proton. This is also a correct statement. Electron has about 1840 times less than mass of the proton there. But now, once we have seen that both statements are true, so now let's again go back to the reasoning part. Proton and electron with same momenta enters in the magnetic field in a direction at right angle to the lines of force. The radius of the path followed by them will be same because electron has less mass than proton. Now you see, this one has no significance in explaining the statement of the assertion. Although mass term is there in the radius expression, but since it is given that they have the same momenta, so in that case, definitely this is constant term. So this is true, but it is not explaining it correctly. Although you will rather see the statement, it will be contradicting that. In the first part, we are saying that radius will be same. And in the second part, mass is less. Of course, it is not the correct explanation to explain the assertion. So obviously, in this particular case, the second one is the correct option. Let's now take the fifth one. Again, let's see the different option. Again, it is the same options there. Assertion, reason, both correct statement. Reason is correct explanation of the assertion. Second one is that assertion, reason, both correct, but it is not the reason is not the correct explanation of assertion. The third one, assertion is correct, reason is wrong. And the fourth one, both are wrong. Let's now take the statement. Assertion is, on increasing the current sensitivity of galvanometer by increasing the number of turns, may not necessarily increase its voltage sensitivity. Okay, first let's see this particular statement, whether it is, what is the status of this. Current sensitivity, you know that if I take current sensitivity, it is your NAB by C. N is the number of turns, A is the area of the coil, B is the magnetic field, and C is the restoring couple per unit twist. Because this term is basically theta by I, and that one gives you this value. If you take voltage sensitivity, this will be your theta by V, which is basically theta by I into R. So in that case, it is your NAB by C into R. So that means you can say that it is your current sensitivity divided by R. Now here, statement wise, if you see the different terms which are there in current sensitivity, NAB is there, C is there. In voltage sensitivity, one additional term is there in the denominator, that is your R. That is the resistance of the coil. Now here, it is saying that on increasing current sensitivity of galvanometer by increasing the number of turns. If you are increasing number of turns, you are changing N. So in that case, what happens? Current sensitivity will increase. But what will happen to the voltage sensitivity? Because if you just see in this way, it is a current sensitivity by R. If current sensitivity is increasing, then voltage sensitivity should also increase. But there is the term number of turns has been increased. If you are increasing number of turns, then the resistance of the coil of the galvanometer will also increase. So current sensitivity will increase depending upon how much is the number of turns by which factor it has been increased. Resistance term will also increase by the same factor. So if you take that, the term will get cancelled, and in that case the voltage sensitivity will remain same, although current sensitivity term has increased. So when it is said on increasing current sensitivity by increasing number of turns, voltage sensitivity may not necessarily increase its voltage sensitivity. So it is the correct statement. The second one is that resistance of the coil of the galvanometer increases on increasing the number of the turns. So this is also a correct statement. If you are increasing the number of turns, then the resistance of the wire of coil will also increase. And if that one is increasing, definitely the resistance of the galvanometer will also increase. So in that case, this is also true. So now again, just go through the statement. On increasing the current sensitivity of galvanometer by increasing the number of turns may not necessarily increase its voltage sensitivity, because the resistance of the coil of the galvanometer increase on increasing the number of turns. So here it is the term may not necessarily increase. So obviously in that case it is explaining it correctly why that particular statement which is there in the assertion is correct, and the reason is also there. It is since a term may not there, so definitely in that case this is the first one which is the correct one, because it is explaining that part. Remember, if it is saying that on increasing the current sensitivity but resistance, the number of turns of the coil is not mentioned. If it is said that on increasing the current sensitivity of galvanometer, voltage sensitivity may or may not increase, because if it is just said that current sensitivity is increased, it may increase due to a change of N, it may be due to a change of A. So in that case, there will be the factor, this voltage sensitivity, which may change, or it will have to see that it is also changing by the same amount. So in that case, it is there. If you keep the R same, in that case, it will be the same case for the two. So here, assertion and reason both is correct. So first one is the correct option. So these are some of the questions which we have done, which were there in the CBSE sample paper released by the board. We'll discuss more of such assertion and reasoning type questions on different chapters in the coming discussion.